Hey guys, today we're going to talk about rational functions and asymptotes, which is found in section 2.6. Our objectives are to find domains of rational functions, to find horizontal and vertical asymptotes of graphs, and to use rational functions to model and solve real-life problems. So just a little vocabulary. It says a rational function can be written in the form f of x equals n of x divided by d of x, where n of x and d of x are polynomials, and d of x is not sorry, I think I made a typo. It's supposed to say not the zero. So not the zero. Polynomial. In general, the domain of a rational function of x includes all real numbers except x values that make the denominator 0. So again, the domain of a rational function of x includes all real numbers except x values that make the denominator 0. And we've talked about that before when we've talked about domain and range. Remember, essentially that last sentence is a x such that x is all real numbers except x equal to whatever number would make the denominator 0. So that's essentially what that is. All right, so for this first one, we're just going to find the domain, and that one's not too bad. In other words, I need to set the denominator equal to 0. So if I set the denominator equal to 0, this is the only value that would make this is the only value where x does not exist. So we would write our domain as x such that x is all real numbers except x equal to 0. That was a bad brace. Oh well. Or you can say from negative infinity to 0 and 0 to positive infinity. Remember, we're using parentheses on the infinities because infinity cannot be bounded. And also we're using the infinities on 0 because it's saying up to 0, but definitely not 0. Let's keep going. So to find vertical asymptotes is the same way that you find domain. In other words, we just set the denominator equal to 0. So let's take a look at how to find vertical asymptotes. We're going to look at horizontal asymptotes next. So to figure out horizontal asymptotes, you check the powers of the leading terms of the numerator and denominator. So if the numerator is greater than the denominator, there's no horizontal asymptote. If the numerator is equal to the denominator, then the horizontal asymptote is a fraction of the leading term's coefficients. And if the numerator is less than the denominator, then there is no horizontal asymptote. And specifically, I want to point out if the numerator is greater than, there's no horizontal asymptote, and it's because there is a slant asymptote. And to be honest, we'll talk about that later, but for what we're talking about, just leave it as no horizontal asymptote. All right, so in example 2, it says, what is the horizontal asymptote of the following functions? So we focus on the powers of our leading coefficients. So in the first one, f of x, the numerator has a power of 1, and the denominator has a power of 2 as the leading terms powers. 1 is less than 2, and so since it is less than, the horizontal asymptote is y equals 0. So I would say HA is y equals 0. Okay. On the second one, the leading terms coefficients powers are both 2. So that means since they're the same, the only thing we can then focus on are their coefficients. So this horizontal asymptote is actually y equals 2/3. In other words, I have to create a fraction based on the coefficients of the leading terms. In try 2, it says, what is the horizontal asymptote of the function below? Again, we're checking our powers. So I have a 3 and I have a 2. Guys, 3 is greater than 2. We know that. So since it's greater than 2, there is no horizontal asymptote, because later there will be a slant asymptote, but right now we won't talk about that. Let's keep going. In example 3, so it says for the function f, find first the domain, then the vertical asymptote, and then finally the horizontal asymptote of f. So let's get started. So to find the domain of f, remember that means to set your denominator equal to 0. So to set your denominator equal to 0, we'd have 0 equal to negative 4x cubed plus 5. Okay, if we subtract 5, because we're just solving for x, we have negative 5 equal to negative 4x cubed. We would then divide by negative 4, and we'd have 5/4 equal to x cubed. Finally, we would take the cube root of each side, and we would have x as being equal to the cube root of 5/4. So when we state our domain, we would say that x, such that x is all real numbers except x equal to the cube root of 5/4. And we could throw that into our calculator to get an actual number. So for part B, to find the vertical asymptote, our vertical asymptote is what we just found, which is the cube root of 5/4. But just so that number makes a little bit more sense to you, if you threw that in your calculator, it would be about 1.08. You don't have to write it in decimal form. In fact, I encourage you not to. But if you wanted to have a better understanding of what that cube root of 5/4 number is, then you could throw it in. And then the last step is to find our horizontal asymptote. So again, we're focusing on our powers of our leading terms. So I have a cubed and a cubed. Third power and third power, since they are the same, we're just going to focus on their coefficients. So the horizontal asymptote is y equals negative 3/4. All right, let's take a look at our next one. All right, in try 3, we need to identify the domain, vertical asymptote, and horizontal asymptote of the function below. So first thing that you should do if you're faced with something like this is that you should rewrite each polynomial of the numerator and denominator in standard form so that you won't make mistakes. So for example, 3x plus 2 is fine, but it should be negative 2x plus 5 for the denominator. Otherwise, we may mistake our our horizontal asymptote as another number. Either way, for the domain, remember that means set the denominator equal to 0. So we have negative 2x plus 5 equal to 0. So if I subtract 5, we have negative 2x equal to negative 5, divide by negative 2. And so we get x equal to 5/2. So what that means is that our domain is x such that x is all real numbers except 5/2. For part B, we need to find the vertical asymptote. So to find the vertical asymptote, we've actually already found it. Our vertical asymptote is x equals 5/2. Or you can say 2.5, doesn't matter. And then the last one, the horizontal asymptote, this is the reason why we switched them. Their powers are 1, so they're the same. So you need to be sure that you focus on the coefficients. And so our horizontal asymptote is y equals negative 3/2. Had we left it like we originally had it, we may have said that, 3x or the x coefficient or the power of x is 1, and that 1 is greater than the power of 0. And so we may have said that there was no horizontal asymptote. But again, if you put it in standard form, you won't make that mistake. All right, with example 4, it says what the horizontal asymptote of the function below. So on this one, we kind of have to be careful. It's almost like we need to create a piecewise function because technically, since it's being divided by an absolute value, we need to take into account both options of x. So in other words, we will have f of x equal to x plus 10 over x plus 2, and also x plus 10 over x, or negative x plus 2, sorry. And so with that being said, for the first one, they're the same, right? So that horizontal asymptote is just y equal to 1. However, on the second one, yes, they're still the same. The powers are still the same, but the coefficients are different. So now we just have 1 over negative 1, which makes it negative 1. So we have 2 horizontal asymptotes for this one. So if you ever experience something with and the absolute value, be sure that you take into account both options. In example 5, it says a utility company burns coal to generate electricity. Suppose that the cost C in dollars of removing P% of the smokestack pollutants is C equals 80,000 P over 100 minus P, where P is between 0 and 100. State legislature is considering the removal of 90% of pollutants. If the current law requires 85% removal, how much is the additional cost? First, let's find what the cost is at 85%. So at 85%, we would have C equal to 80,000 times P, the percentage. Now the percentage is just going to be written as 85 over 100 minus 85. If you throw that in your calculator, you'll get about 453,333. Okay. If we do the same thing with 90%, we'd have 80,000 times 90 over 100 minus 90, which gives you about 720,000. So if you subtract them, it says what is the additional cost, so we need to subtract them. So 720,000 minus 453,333 will give you about 266,667. And that's it. And on example 6, it says the business has a cost function of C equal to 0.5x plus 5,000, where C is measured in dollars and X is the number of units produced. The average cost per unit is C bar, which equals 0.5x plus 5,000 all over X. Find the average cost per unit of 5,000, 10,000, and 90,000 units. What is a horizontal asymptote and what does it represent? So let's first start with the horizontal asymptote. We would look at this, and I need to change this around because it kind of looks funny, but this function here, C bar, which C bar, the bar on top just stands for average, so it's the average cost, is 0.5x plus 5,000 over X. So since I'm looking for the horizontal asymptote, I would look for the powers of my variable. They're the same. So then I would focus on their coefficients. So the coefficients as a fraction, the horizontal asymptote would be y equals 0.5. All right, now let's just go and answer the question. The question asks, find the average cost for 5,000 units, 10,000 units, and 90,000 units. That's nothing but substitution. So that would be, for example, C bar equal to 0.5 times 5,000 plus 5,000 over 5,000. And that gives me $1.50. If I do the same thing with 10,000, that'd be 0.5 times 10,000 plus 10,000 over 10,000, which gives me about, or actually gives me $1. And the last one, using the same function, C bar equals 0.5 times 90,000 plus 90,000 over 90,000. That gives us about 56 cents. In other words, as the units increase, the average cost decreases. And that kind of makes sense because usually in the real world, the reason the cost decreases is because you can get bulk items for cheaper. Anywho, guys, we are done. If you have any questions, please be sure to stop by for tutoring.